Hello, everyone. Welcome and thank you for joining us today. I'm pleased to introduce you to an innovative project that stands at the crossroads between artificial intelligence and the insurance sector. Our team, led by Agustin, together with Gustavo, Juan, and me as well, guided by our mentor Alan, has embarked on an ambitious journey to revolutionize the way insurance companies interact with their customers through the power of technology. Our world is changing rapidly with the AI at the front of this transformation. With this in mind, we have focused our efforts on the healthcare insurance industry, an area ripe for innovation and improvement. The cornerstone of our project is the development of a conversational chatbot designed to provide users with specific and relevant information about their insurance policies in real time. This initiative is not just about leveraging existing technologies, but pushing the boundaries of what is possible. Our main goal is to streamline the traditionally lengthy and complex underwriting process by employing a chatbot that acts not just an assistant, but as a trust advisor using the latest technologies in natural language processing and machine learning. Our scope encompasses several key deliverables connecting to AWS for database access, performing extensive exploratory data analysis, deploying a vector database, creating an generation procedural chain, and developing a web chat user interface. All these elements are brought together in a seamless containerized Docker environment, complemented by the policy new web scraper and a conversational language learning model agent equipped with the latest tools. Through this brief presentation, we will go in depth into each stage of the process of building of this MVP project. So like the technologies that were chosen or the reasons, how the architecture was designed and how each separately designed year was unified. Then Agustin is going to show us a live demonstration of the chatbot, and finally we will be able to ask us any question you may have during the presentation.
As main technologies, we choose OpenAI for the large language model using GPT-3 Turbo, and we also used the embeddings from OpenAI to transfer the information into the vector database. As the main framework, we choose LangChain within another options. And for the web interface, we use Chainlit and Qdrant for the vector database. Finally, we use Docker to build the microservices and, of course, Python to develop the whole project. As a whole picture, we have this architecture. We have three main services in two modules or blocks. And we have the first module called injection, which runs only once in the beginning when the information is loaded into the database. And as we said, it runs only once when the information is provided, and we have developed an interface to interact with the operator who loads the information. It can also run automatically, sorry, and create the vector database when we load information. The other model has the other two services. The first one is the vector database, which also receives information from internet through web scrapers. And finally, the backend UI to provide the user interface and interact through the main framework with the agents and the database. The information provided is basically a collection of files with up to one up to 5 policies per document per file. And each policy is divided by articles following more or less the same structure. And in order to get the information from the raw text, we use regular expressions. And then after processing the text, we load through using embeddings into the vector database, creating 3 different representations of the information. One's at the top level, which is representing each policy as a feature. Then a second level based on the article contents. And finally, a third representation based on the article's headers. This the idea of create different features on the information is to have some kind of redundancy and get different representations of the same files into the vector database. Finally, we have finally no, sorry. We have this second module which has the backend UI, as I said before, which has the main framework with the agent and a collection of tools that Juan, my colleague, will explain now.
Thank you, Gustavo. Hello, everyone. I'm going to tell you what is Chainlink. It's a platform that provides a comprehensive solution for development and management, allowing users to create effective and personalized conversation experience. It allows you to design and customize the chatbot dialogue flow using an easy-to-use graphical interface. It allows you to connect the chatbot with the different services and external API to add additional functionality. Make it easy to manage and organize chatbot content, such as predefined responses, images, videos, and other multimedia. Why do we choose Chainlink? Mostly, we chose Chainlink because it allows chatbot to be implemented quickly and easily. Compared to other frameworks, we found it more chatbot-oriented than Chainlink and easier to implement than Gradio. Chainlink also offers minimalist, pleasant, and intuitive graphic style that significantly promote a great user experience. About the main UI element, as we can see in the slide, on the left of the application header, we have the chat button that allows us to position ourselves in the active conversation with the bot. Then we find the README button that shows us a welcome message with instruction for the user. To the right of the header is the new chat button that is used to open a new conversation thread. At the bottom of the application, we have the text box so that the user can ask the chatbot any question they want, sending them with the airplane shaped button. In the body of the application, we'll be able to see conversation arranged chronologically. At a glance, you will be able to identify which line corresponds to the user and which line to the bot. On the right side, we find a container where the text track corresponding to the policy related to the bot's response are displayed. Additionally, in the upper right part, we find a button with the avatar of the active user that allows us to access some settings such as changing the graphic theme. How we customize the UI. Chainlink offers the possibility of customizing the interface very easily by editing the config YAML file. In the last line of the file content, we find the necessary parameter to change the color. Ok, agents. Esta lo voy a leer porque tengo que armarlo. The agent has 4 tools and the user query will make to the model decide which tool to execute. The agent tools are policy tool, share information about the word policy without any count. Content tool, pre-processed content of the whole article for a particular policy. News tool, web scraper for searching for Instagram policy, company news on the internet. And CL Consti tool, web scraping for searching for some article in the Chile Constitution. The agent can execute a tool more than once and also execute different tools sequentially. Next, my colleague Agustin will show you in detail how the application works.
Okay, thank you, Juan. For beginning with the presentation, first I want to show you that both containers are uploaded and running. We need to enter to the local host 8000 in order to access the front-end interface that my colleague was explaining. So here we are with the chat loaded. We are gonna start asking for a recommendation for a policy for a particular client. The chat works in Spanish, so the prompt it will be written in Spanish also. In this particular case, we are asking the model to recommend only one policy for a potential client that has a heart disease. So we can see that the Seguro Individual de Enfermedades Graves is the policy recommended for that particular client. But moving a little forward, we can ask the model to recommend some complementary policies for this particular case. So recomendar pólizas complementarias para la póliza recién mencionada is the prompt that we are getting the model to recognize in the chat history what was the first policy that it was recommended. In this case, Seguro Individual contra Enfermedades Graves. And as we can see, the model recommend 2 more policies that could be complementary to the first one. This information, as my partner mentioned, is down here on the sources. It will pop up the right column, and we can see the information that comes from the vector database. So this information right here is the content, the context of the model to answer the question. So we are going to try the next two about the information of a particular policy. So the first one was Seguro Individual para Enfermedades Graves. So I personally recommend, instead of copy and pasting the information over here, to search for the information over here, because it's straightforward from the vector database. So the Seguro Individual de Enfermedades Graves is right here, and the articles are all over here. So if we choose, for example, Declaraciones del Asegurado e Indisputabilidad, we can ask for this particular article using a prompt, something like this, like explain the article, declaraciones del asegurado e indisputabilidad for the policy seguro individual de enfermedades graves. So if we run this new input, the model will respond using the content of that particular article. As we can see, the previous answers were with using the policy feature tool, and here is using the content feature tool. And if we enter to the source, we can see that the current article was exactly the one that we were asking for, like seguro individual contra enfermedades graves, and the article declaraciones del asegurado e indisputabilidad. And here is the answer from the model for that particular article. Well, moving forward, we are going to test another tool. For example, if we enter to any policy and we search, for example, for one of the mentioned article of the Constitution of Chile, we can ask the model to explain about that particular article. So for executing that tool, we are going to write a prompt something like this. When we write Constitución de Chile, we are sending a signal to the model that this particular tool, it must be executed. So now the source comes from the CL Consti tool, and the article selected was the Código Penal artículo 470, and the article number 10 is right here and match exactly the description over here. So the last tool that we need to show in this demonstration is the news search. So we are going to put a prompt that says when we talk about noticias and internet, the model understands that is the other tool, the web scraper tool that has to be executed. So web news tool is the corresponding tool, and this tool is set up for recommending only recently news. Everything that is from the last year, it will not be recommended. And if we enter to the links that are on the response, we can see that actually the news is correct. Well, this is all for the demonstration, for the demo live demonstration. Let's go back to the slideshow. Well, in order to continue with the presentation, we have prepared some future features. There are like components that must be built in order to put this application into a scalable and production-ready state. The first future feature that we want to talk about is the problem about bias that has all the retrieval augmented generation chains that are the kind of chains that we are developing. The problem is explained in this particular article, but it says that as the human brain, when we add content to a large language model, the model has the capability to pay attention only to the beginning and at the end. And at the middle, there are some parts that are lost. So This problem has many solutions, but currently we have like two mainly approaches to solve the problem. One of the solution is to mix two search engines. We need a search engine algorithm that goes and asks into the vector database with a similarity search. And we also need another search engine with a semantic algorithm. If we have both search engines, we can merge them into a tool that is called Lord of the Retrievers. Another solution is to explode at the maximum the similarity search engine by adding a large language model that can transform the user query into a more related prompt for that kind of vectors. And in that particular case, we can explode the approach of similarity, transforming the user input. Well, in summary, since a lot of articles are very large in content, are too large in content, we cannot afford the first solution. We need to afford the solution where a large language model receive the user input and transform that user input in a relative prompt. But in order to do that, we have another question. If we will add a particular large language model to all the tools, or if we going to develop a reasoning tool that will execute first of all other tools. So in that particular reason, the reasoning tool is the best approach for the bias that our model could face when the user makes some inputs. The second feature that we want to talk about is about the expansion of the architecture. There are right now we have the agent, the large language model, and all the tools developed in the same service at the user interface. And in the local pipeline, we have all the resources to storage all the vectors, the embedding vectors, into the vector database. So the expansion attempt to remove the agent from the backend UI service, where the interface is, and develop in the injection service, and then communicate both services through an API REST. So, in order to communicate both servers, we will need to develop some other technologies, for example, LangServe, in order to integrate the API REST for our model. And also, we will have to implement Langsmith in order to monitorize and test the conversational agent. When we achieve the state, when we have the agent in the injection services, we will be able to develop more complex retrievers, since we will have the local files in the same service as the agent, and the agent could reach from the local files that right now it couldn't. And also another potential situation is that if we remove the agent from the interface, we have a lot of features that we can develop for the interface, like for example user and session management, in order to have more than one user and that the user have more than one session. Well, the final thoughts. We are at the end of the presentation, and we want to share some personal thoughts with you, because nowadays we are working with technology that has recently seen the light, and the challenges will keep coming with all the changes that we will be facing through the coming month. In this particular case, we are working with LangChain and the LangChain interface, the LangChain expression language. It was published on August of last year, so it has less than a year. Another thought we want to share with you is that our priority on this project were knowledge and experimentation. For that reason, the most important thing to solve was having a solid architecture, but we think that we have a lot of space to move forward in that direction. We are currently facing a new trend in the way people interact with organization. The experience that generative AI offers is the new way in which we will communicate with organizations. The chat models are not also a new trend, it's like a new way for communicating with organization by replacing forms, but also I think that it's going to be a new way to communicate organization between their internal agents. And the last thought we want to share is that companies that could afford having a research and development department could have the better profits about the great potential and experienced customer that this kind of technology can offer. So we are like completely open to keep working with this project. Okay, thank you. We have reached at the end of the presentation, and we are open to questions from you. Thank you.